Okay, so welcome to the December Tanka community call. So I was thinking just to start with, we could might be good if we could just say a sentence about what brings us here, and then we've just got a couple of topics to present, and then we can use the rest of the time for general Q&As. So I can start. I'm Malcolm. I'm part of the newly renamed platform squad at Grafana Labs. We make heavy use of Tanka, obviously, and you know, I've had some dabblings with the Tanka code base itself. Probably some of the simpler features are my responsibility. Yeah, that's me. You're on. Do you want to say something?
Yeah, sure. I'm an SRE at Grafana Labs, joined a year ago, and I am very happy with the Tanka tooling as it was there in the first place. And I started adding more features on top to make my life easier.
Great. Anyone else want to say anything?
Hi, I'm David. I'm coming from Ubisoft. You must know there's Ubisoft expat that is working for you right now. I think he's working on Loki. I don't remember his name on the top of my head. Anyway, and I'm looking to help automate our deployments. And we've developed a small tooling to prepare with Tanka manifests and to easy onboarding of people that are not very used to Kubernetes. So we just have a small top-level manifest, and with Makefiles and Tanka, we create environments. That's why I'm really interested with the inline environments feature. So we create the sites for exporting, and that's it. It's a tooling for 80% of people coming to Kubernetes. They just want to have their service set up and not having too much fuss around with Kubernetes. So.
Yeah. Thank you. Anyone else want to introduce themselves?
I will. Yeah, I'm Tim. I'm at Yelp, SRE at Yelp. Yeah, so for the past few years, we've been running Prometheus on EC2 instances, and we're starting off a migration to Kubernetes using Kube Prometheus and EKS. We've also got like a in-house platform as a service that is running on Kubernetes as well. And we're starting to use Tanka to model out our Prometheus shards. And similar to David was saying, like using a series of Makefiles and Tanka to like allow teams to go and create themselves a Prometheus shard.
Yeah, maybe a couple of words to myself. I'm an SRE at Tau Testing, open source assessment platform, and we're currently transitioning from a plain JSONNet stack to Tanka in order to ease our lives a bit.
Great. Thank you. Matt, do you want to say something?
Yeah, I just realized I'm double booked between this and the TOC call for city observability. So I'm going to have to drop out, unfortunately, because we're presenting some stuff. But my name is Matt. I'm from a company called EverQuote, and we're moving over to using JSONNet for most of our configuration and Tanka.
Sorry about that.
I've created a GitHub org, Tanka Tools, where we intend over the next couple of weeks to open source most of how we're doing configuration for Cortex, Loki, Grafana, Prometheus, and Cortex.
I'm not sure about
so yeah, I've been studying on Tanka and pretty enthusiastic about it.
So I put in.
Great, thank you. So sorry you can't stay.
But luckily that.
Yeah. Oh, and my update is on Friday. I finally got with our general counsel. I got clearance from the tower to proceed with actually putting what we're doing out in the open. In short, we're running all this on EKS in a secure way with service accounts and role bindings and all of the stuff you have to do with annotations and whatnot to do EKS fully when you can't use a default service account. So most of my changes to those various projects that will be PRs in the next week or two are stemming from that.
Thank you.
Really.
And that was for watching the recording. I'm sorry for listeners.
So, so let's head over to Euron. Do you want to give your presentation? Assuming you've not frozen.
Yeah,
what?
no, I'm not frozen. I'm just muted. As usual, I forget. I can demo something with inline environments. So it reached master last week. Yeah. There was a lot of discussion because it's actually a major feature. Do it differently, and it has some. It might have some drawbacks and discussion about convention and whether it's convention or Tanka should do it for you, things like that. One moment. Yeah, sorry about that. Got some noise from the blinds going down. So yeah, I can show you a bit on how to convert a regular setup with this main.jsnet and spec.jsnet into one with an inline environment. I think showing it is the best example, is the best way to show an example of how it works. If it will work with me, yeah. It's an internal one. For a dev instance, there shouldn't be no secrets in here, but if so, don't look away. We have a main.json here, a simple config that is used here and again here. And then two elements, it's Pentagon that we use to sync our secrets from Vault to Kubernetes, and Flux itself, which we install also with a feature in Tanka using the Helm chart from Flux v1 to be clear. This is the spec.json that goes for it. Just as API server, what you used to, some labels that we add, as we also want to let Flux deploy itself, what states it has and which team it owns. This renders as a regular one. It ends up with a Flux CD block with a lot of manifests for everything, as you would expect. Yeah, that's a really simple one. Let me show you how I would convert this. First, I would create an env. Can read spec.json. There we go. Oh. Now we already have the env here, and all we can add here is a data block. This is really fast and dirty, but here we have Pentagon. Pentagon comes from downstream Pentagon, what we already configured, and Flux CD, which is the downstream Flux CD. And then, because we don't want to render it twice, we hide this. Yeah, that's the basics that we need. And it's done already. We can delete what's in here, but we can delete the spec.json file. Let's do that. There we go. Now it's only main.json, and let's eval that again. Now we have the env with the data. fold, clean fold. That's that, which is the really simple part. Just move it and add it. Are there any questions on this one? I got a follow-up one, make it more advanced.
I guess my the obvious question is, yeah, so you've moved file from one place to another. Why do it?
Why do it? Let me give an example. One that comes from the issues is that you want to make this one an input variable that you, because you run a local Kubernetes cluster to test it somewhere. And I heard it, I think, from GitLab. There were some people that run a local cluster to run tests, and there they want to provision the API server, and that's each time a different IP. So let's say you want to change that. What you can do is make that a variable and make this a function. Right? Make that a little bit cleaner. Don't save that. And then you have this thing that comes from a top level arguments that comes from JSON. So it's just plain JSON stuff. You can set this API server to something else. And this is really interesting to play with these things. I have another example, and that's way more elaborate. I've been writing a demo for internal to show internally how that might work. There we go. So here we have that's clean. We have a few different systems. It's the naming is here cluster name dot namespace, which is a convention we use, and inside that we have names a main.json. What would render to an env. And actually, I made it really simple, and it looks like this. This is all that is left from an environment. All the rest I program with JSON. So we have amps.json, which is a huge list of all the information I need about the clusters we have. And that you can use all over the place for every project you have, because you can render this with Terraform, for example, the tool that sets up your Kubernetes cluster. And you can load that into a file and say we loop over that. So we have amps.gke, amps.aks, apply a function to that, which adds an env to it, which sets the namespace, adds some specific config to it, exceptions for Google projects, for example, and then you render this env. Which is also now a function in here, but you can put that somewhere else in the library, so you have all environments for your project with the same configuration for environments, which is just here. It's the same thing as we see before, only made a bit more specific for what it is, but general enough to be used by different things. So yeah, it's really fun just to have the spec as a programmable object here to use. That was a really quick run through to all the things that I've already done with it. Feel free to ask questions or find issues with it. It's all very new to us too. Yeah.
Thank you. So, I mean, one of the things that we get with this as well is the stuff to do with, you know, at the moment there's a TK, you can import to TK, which gives you access to things in your environment and so on. And it also causes all sorts of problems. So here, if you want to, for example, the namespace, you can just do $.m.spec.namespace and you've got it. So you don't need to now configure namespace in, as you see line 25 on the right. That's redundant because you've also got it on line 16. So there's ways in which we can make our code a bit more compact.
So what's the data key for? I see it that you're referencing the Pentagon, the top level Pentagon object, but
the data level is actually what would previously be in your main.json.
Okay.
Yeah. So it moved one layer deeper. So it's part of an object. The reason for that is not necessarily from a JSON perspective, but from a Tanka perspective, where in development of Tanka, it would be interesting to be able to pass along a complete object, including the spec information and the objects related to that spec, to another component within Tanka. So it's more of a, how do you say, a pragmatic approach there.
So what you're saying is, in the same way as you might have a deployment in Kubernetes, and that deployment has containers within it. So it's one thing that describes multiple. In the same way, what we have here is a single thing which has a kind of environment, and what it does is it contains everything about that environment, i.e. all of the resource definitions within it. So that's why Euron moved it from the outside into the data element. And that does actually allow a number of interesting things that we'll mention in the next topic.
Yeah. One of the questions that will probably come up, and as far as I know, there's no answer to that. When will this be released? Well, the next version, but that's not planned yet when that comes out. But use master, right?
The makefile system that we've set up in-house caters for this use case only for injecting the server label, I think. So we set different directories for different environments, and we use a base template of a spec.json, and then we replace this with JSONet. So yeah. So I think I'm not seeing it how we could do it, because we're generating for the user. It's nice to see different environments in the folders already, but the templating could be replaced, I think, with this feature. I'll try to play with it in the following weeks.
Great. If there's no other questions or anything, we could keep going.
Yeah.
Okay, so yes, I do in fact have it still. So in the doc, I'm going to paste a definition that we came up with when talking internally of what Tanka is. I can paste it into the chat here as well. this is not so much a statement of what Tanka is right now, but more to try and capture our imaginings of where it might go. So Tanka is a tool for managing Kubernetes workloads that also plays well with similar JSONet-based configuration tools. This means it structures its Golang code to maximize reuse by other tools, whilst entirely focusing on its own use case. It avoids opinions that block other tools from consuming the same JSONet codebase. So you'll start to get the feel for where we're going when you now reflect back on the inline environments. So at the moment, if you have a resource, if you have anything in your Tanka, in your JSONet output that is not a Kubernetes object, Tanka will complain. And so the Tanka, the JSONet codebase is whatever JSONet code you're using is going to be a Tanka codebase. Whereas what we're moving towards here is, for example, we have a much smaller but a useful tool called Grizzly that consumes JSONet, but instead of talking to a Kubernetes endpoint, it talks to a Grafana endpoint, or actually it does Grafana synthetic monitoring, and Prometheus/Cortex ruler for uploading Prometheus rules. So it can talk to various endpoints. So what we can now do is have one code base that can be consumed by multiple consumers, for want of a better term. So in a way, what that's saying is that's where Tanka avoids opinions that block other tools from consuming the same JSONet codebase. If everything is in an env environment, and that environment is labeled with an API key of Tanka, then if it comes across something that's not an environment that has an API key it doesn't recognize, Tanka can just say, I don't know that, I'll ignore it. Yeah, and that way we can put in there another thing, maybe that is a Grizzly environment with a Grizzly API version, and it can then pull in just the bits that it's interested in and do whatever it wants to with it. So that's the second part. The first part is, well, Tanka's got all of this cool Golang code to do all this stuff, to interact with JSONet and so on. Why would a tool like Grizzly want to redo all of that? So Tanka could itself be increasingly structured as in its Golang code, such that you want to push something, I don't know, to Slack. You can just write a very thin layer on top of Tanka and make your own equivalent JSONet tool to talk to something else. Any thoughts, questions, etc.?
Did you say that Grizzly can push Prometheus rules? Because that's quite interesting. That was something I didn't know.
So Prometheus itself does not support. It basically has its rules written into a file. So you need to find a way to get your rules. If you generate your Prometheus rules from within JSONet, you're probably going to be writing them into a config map or a CRD or something like that. However, if you use something like the open source Cortex ruler, if you're using Cortex, which has its own Cortex ruler, or you're using Grafana Labs hosted Prometheus, etc., or Grafana Metrics Enterprise, they have that the functionality which basically provides you with an API that you can use to push the rules up to it, and that's what Grizzly will write to.
That's pretty cool.
Showing one more time what we had before. This doesn't work, just an example. Well, we could have something like this in a block here where we have this kind Grafana thing, For example, let's say Flux Tanka doesn't understand that, but let's say Grizzly understands that we could execute Grizzly on the same code base that Tanka uses. And then from the same Flux CD that we have below that would provide Grafana dashboards, we could import these and push them to a remote Grafana instance somewhere else that is not per se in your Kubernetes cluster. That was why the data block is separate here.
Yeah, and what this allows you to use other systems that run alongside Tanka, or potentially, you know, what if there was something that just used Ansible to do SSH based stuff or whatever else, you know. It doesn't need to, you know, this JSONic way of working doesn't need to be tied to Kubernetes per se.
I think that's one of the reasons why we all have either YAML or JSON doing things, because they are so interchangeable and easy to work with. So if you have one output moving to another, the same way that we use Helm now, and that's one of the next topics, we can also use customize, for example, in the same way, because it translates to YAML or JSON, and you can import it and use it again and again and port it back. Like you can modify something with JSON, create YAMLs, give it back to customize, for example, if someone builds a tool for that. So, awesome stuff.
So just to say, when you say you can use customize, what you mean is that the master branch of Tanka now supports customize as well as Helm.
Yeah. It's a sneak to the next topic. Yeah, it was actually quite easy because the same workflow applies. Like customize renders YAML, and YAML can be imported and be provided just like Helm. We actually, and that's the funny part, we actually were interested in using the GitOps toolkit from Flux v2, but you have to use their CLI as far as we can tell to deploy that. But we want to deploy it in a GitOps fashion, right? Because we're doing GitOps. So we were like, okay, but how does the CLI tool deploy that? And it actually uses customize under the hood. So why not use customize directly inside Tanka, render the YAMLs, and let Flux v1 deploy Flux v2 for us. And we can do the component base because you have the source controller, and you can deploy the source controller first and not anything else. Yeah, it's a way to avoid using the CLI tool for us. Yeah.
That's really cool, because I was talking about a makefile setup, and one of the things I ended up doing was like putting into the makefile, like converting customize into JSON it and applying that with Tanka. So it's really good that that's built in.
Yeah.
So please, you know, I think it's very much new code. Play with it, try it, come and tell us what's wrong with it.
Yeah. The nasty thing I find about customize is that it's built on the premise that you have an internet connection. It's like you can't just say vendor everything in and render it locally. No, it needs to pull, and you can go as deep as customize can go. So even there's particularly no end, because the next customize can import another customize remotely and again and again. So I think that's the nasty part, and I don't know if and how we are going to solve it.
Yes, so what you're saying is at the moment, when you use the Helm feature, what you do is you vendor the Helm chart into your local repo, so which means it's all, as it were, statically defined. But with Customize, it will be pulled in at runtime, which means you may risk a chance of getting a different thing from two separate runs, which is something we'd rather avoid.
Yes, what we do is we try to have strong reproducibility, and that would, to me, just trigger a thought of maybe not going to that route because we do we have a strong we want it to be local executable, so you can evaluate manifests, and the CI actor or the programmer is the same actor. So the CI does the same thing as the programmer would do locally, so it's really more reproducible. And we use JSONet to generate the CI from GitLab. So we can use all the same configuration from Tanka and in the same code base. So it comes to what Malcolm was saying, trying to not be invasive in the way to do. So we have basic JSONet that can be consumed with Tanka, with JSONet, and so we use JSONet to generate the CI.
Great. Good. Did you have more to say, Jeroen, on Customize other than to announce it?
No, not really. It's just what it is. It just executes. We stand on the shoulders of giants. We don't do much magic here. It just executes the CLI, nothing more. Yeah.
Yeah, and I think, you know, I'm certainly curious to see whether there are other. So in a way, we've got two axes that, in the definition of what Tanka is about that we mentioned previously, it can both work with other JSONic code bases. It can be consumed by other tools that work with JSONic code bases, but it can also consume itself other tools such as Helm and Customize. And, you know, are there other opportunities like that? I'm kind of quite curious what those might be.
Yeah, I don't know if it already is in a release. It's certainly in master. I made sure that the output of TK eval will always render, even if there's no Tank environment there. And I think in the previous version, when you ran TK eval and it didn't have a Tank environment, like a spec.json or something, a spec.json, then it wouldn't work. But now, in at least newer versions, that will. So you can run TK eval instead of running JSONet.
That's actually very nice. This is a feature request I have because we are currently doing a hacky way with Tanka in our CI pipeline. So really appreciate that one.
All right, great.
Good. So I think we've come to the end of the content we prepared. So at this point, we open the floor to anyone who has any questions or anything you might want to ask, discuss, etc.
I have a question, if I can go first. As we're providing a JSONet tooling to users, I find that sometimes the users are in the dark with the template framework that we're providing them. So let's say we say, okay, all these objects will come and you can override. So, and I find in JSONet that it's hard to see what's coming inside to be overridden. I've tried to use std trace, and sometimes it doesn't work because it recurses it on itself, because you can't just say std trace on self. Do you have any debugging tricks for that? Or
for me, I think the biggest one is tk eval -e. I don't know if you've come across that as a example. I'll put it into the doc.
Yes, yes, I use it. Well, I've branded it a render function. So we do render the environment, and it renders the JSON, but you don't have all the JSON magic inside. So you don't have all the overrides, or the raw JSONet is manifested. So you don't see. You know what the keys could be. So it's a tool. I use that for a tool to know what's could be overridden. But I would like to see what's in memory before manifestation. You know, that would be nice to have.
So specifically, the TK eval will output the JSON, the resultant JSON, before it gets filtered for Kubernetes objects. TK eval -e basically does, let me type it here. If I do tk eval environments -foo minus e something, if I were to do that, what it would evaluate is import environment/foo/main.jsonet.something. Yep. So even if main.jsonet has a thing, an element called something, that is private and not visible to the, therefore does not end up in the output. By executing that import statement like that, you can start to extract and explore the hidden elements within the tree.
Would it be interesting to have like a function that makes everything visible, like an eval and then show all?
Absolutely.
Yes.
Yeah. Will be a lot and might render hard. I don't know. I imagine one of the more elaborate code bases we have will take a lot of time to render.
But sometimes it could be less code because it's not manifested, so you won't have all the loops, all the. If you can reflect on the source language.
What I proposed was actually evaluate all, and where it's hidden, don't hit, but it will still render everything. What you maybe find harder is just to, let's say, when looking at JSON, I always imagine the tree of what comes out of it. So I start looking in the tree and don't look at it as JSON. I look at it as JSON, which allows me to find things fairly quick. But yeah, certainly looking at as if it is JSON as a programmer becomes increasingly harder to find back what caused what. One thing that I I noticed someone mentioning in our chat, one of my teammates, Danny, used JQ and the pod to inspect it. I posted here. So you can find a certain key back somewhere in the tree, and the bigger the tree is, you can the easier it is. But then, yeah, you can still fall back to using grep to see where it all crosses paths, right?
That also reminds me that I had to use that JQ trick because the thing I was trying to eval, the key, had a dash in it, and then JSON it doesn't like that because it interprets it as minus instead. So
yeah.
So do you use IDE integrations? I know the Hepio one is like out of sync. It's stopped working. It's not. Do you know anybody that's working on bringing that back into life? Or
I don't. I use Vim.
So Matt, who briefly joined and then left, has suggested you might have a look. But we're still, someone who does that would make themselves very popular.
I'm actually working on something like that. If you're interested, I do not have anything public yet, but basically it's based on a KDS author and a doxanet, and it's just for Vim. It's an omni-complete plugin, but it works kind of. I still have some bugs to fix, but when it's done, I will publish it.
Great. Look forward to seeing that.
Yeah, definitely look forward to seeing something that is the start of a language server, and then see where it ends. I guess I don't know how complicated it is to write something like that.
I think one of the things I will just say to David is I don't know if you're aware of this particular perspective, that what a lot of JSONet code does, and a way that JSONet was used and has been used for a few years is you can you can add all of your libraries to the global namespace, and all of your libraries can then cherry pick what bits of the entire JSONet tree they adapt. Now that is, so for example, you install a Grafana instance, and the Grafana instance says, oh, I want to be monitored by Prometheus. Oh, I'll go and add some scrape configs to Prometheus in order to get myself monitored. And that assumes that you've also imported a Prometheus and you happen to know the exact path and exactly how to tweak it. It's extremely powerful, but you also end up with extremely tightly knit code. So what we've been doing a lot more is creating libraries that we consume as say for example as a local, or as a hidden an element where you use the library. So you don't add them all to the root, but you keep the libraries encapsulated. What you get then is when you invoke a library, you're deliberately saying, here is the config element that I want to provide to this library. So I'm being very explicit about the configuration it's getting, not allowing it to wander wherever the hell it likes. Yeah. So changing your programming metaphor in JSONet, I tend to use the not very flattering analogy of if you were writing Golang, would you write your entire application in main.go? Often it's that kind of, I think,
globals.
Using globals, yes. It's something that in most programming language would be extremely, probably apart from BASIC, would be extremely, encouraged against or discouraged. So yeah, that's something that we've learned about how we write our JSONet, is to actually think about how would I do this in a different programming language, and how can I make sure that I'm creating reusable objects where you hand in a predictable a known set of inputs and get an output of a form that can be managed and interacted with.
Yeah, so in our case, where we say, okay, you have the main.jsonnet in Tanka, override what you need to override. We have only one site, so that promotes this one file organization. So I guess we now need to propose to the user entry points to different customization points, so they could provide focalized overrides. That's to think about.
Yeah. So really, I don't think there's any sense in which I can say we've succeeded at this, but I'm suggesting that main.jsonnet should not have any reference to Kubernetes in it. So main.jsonnet should say, you could say, I want a MySQL and I want an Nginx with PHP with WordPress installed. Yeah, and you could say, give me these three things. But then actually, I could make a library that creates those three things and then say, give me a WordPress. And so all I say is WordPress.new bracket name of the site, and then I handed a config which says what's the domain name, what's the size of the disk it's going to use, blah blah, database password, all that stuff, and it then says, okay, well, I know what to do with all of that. Then it returns you a blob of JSON, and then maybe you can have you can say plus WordPress dot and then have other functions or other elements that patch and adapt that behavior to add new functionality as you go. And then your main.json, it becomes much more descriptive of intent and much less about implementation detail. So encapsulating the chunks of functionality as we would, again, in any other programming language. We would write functions and encapsulate and classes and all that stuff.
I can, if you want, if anybody's interested, show a badly written main.json and show how to write it better, at least to our standards. Let's see.
Let's check. Does anyone else have any other topics they wanted to raise, or should we go with Euron's suggestion?
There was one thing I wanted to ask about, but I do want to see the example as well. So.
Go ahead.
Go for it. Do you want to ask your question now, and then we'll
Sure. Okay. So I mentioned that we've got like we're using EKS and we're using Tanka to apply to that fine, and we've also got like our in-house Kubernetes cluster, and like one of the pieces of work that's being done at the moment is to change the authentication of that so that we use Okta, which is like an SSO provider, which means that you have to run kube control with the -- token option. Now Tanka just runs kube control directly, doesn't it? I don't think there's any way to set any other options to what you're running kube control for. Now, yeah, I know the answer might be like pull requests are accepted, but that's the problem that I might have.
You can configure a few things, definitely when it comes down to environment variables. For example, override external diff stuff for kubectl.
And that would allow you to pass like arbitrary options to kubectl. That's cool.
Maybe. I don't know about arbitrary tree options, but I know about if it is an environment variable in kube control, it will get passed. So it runs in the same environment.
Okay, that's something to look at. Yeah, if I can pass that as an environment variable instead. Yeah.
I'm going to rejoin because my browser is a bit broken.
Does that answer that question? And how else would you provide the information to kube control?
So there's a -- token option that when you run kube control. So you were running kube control diff -- token and then pass the token that you've got back from Okta. So it might depend on if that is supported as an environment variable in passing as an environment variable instead, which is something I don't know. I can look at that. But otherwise it might have to be changed in the way that Tanka calls kube control.
Yeah. I mean, I think your answer, your previous comment is also absolutely valid. You know, if that is something that can be justified as a way of interacting with Kubernetes via kube control, then a PR would be, if you're versed enough in Golang. If you're versed in Golang, a PR. If you're not, an issue.
Mm.
Mm-hmm. A quick Google of the kubectl_token environment variable gives me a bunch of results, so there is a chance. I just didn't find the documentation entry that quick.
That's I'll definitely go and have a look at that, and if not, raise an issue or a PR.
How it will work. I have this, for example, kubectl external diff. And
okay.
Yeah.
I just to set. It says when using kube control, use your ID token with a ---- token flag, or add it directly to your kube config.
Right.
But then I guess if that token keeps changing, then that becomes impractical.
Yeah.
But I think there are ways you can invoke things. I know in EKS they do that in kube control. You can invoke a tool that goes and calls out to the authenticator, gets your token, and then provides it to you, which is probably the best approach to take.
That's a really good idea as well. Yeah.
I am AWS Authenticator or something like that. Does it?
Interesting. Yeah, I used the token in the past too, so fairly recently. Yeah, I can give one more demo before time runs out. So I have this thing where we have everything we import added to the global scope. And all that's here, except for looking at naming, you actually don't know who consumes what. So you have to take a wild guess based on naming. It seems obvious that autoroute is used by autoroute and Pentagon mappings by the Pentagon library. And that GCR name possibly comes from the GCR library. But then how or what and why is it all mashed up together? That becomes really hard. You totally don't know who's using this. So what I usually do to write it differently is encapsulate that in autoroute something. So that's that. And start pulling things out. Like I know this because I know, I'm not going to take into that, that Pentagon and GCR belong together because of the, we get the secret from there, and Pentagon writes it from Vault into Kubernetes. And what it needs is at least the Pentagon mappings. So we end up with Pentagon mappings here. The Pentagon also needs config to have the namespace and the cluster name, but also autoroute needs that. So they both have the same config here that they need. So I'm going to pull this out and add it here. That's gone. So we take _config. Here config also has _config. So that's a lot cleaner already. And now I know the last thing that is here is that the GCR secret name comes from the Pentagon block. So I add here .pentagon. And that's it. And now we know each piece of config that was previously there, who consumes that. Config is consumed by both. Autoroute is specific to autoroute, and Pentagon specific to Pentagon. And this renders the exact same YAMLs in the end. No more global scope. Anyway, just showing off.
I think I'm going to enter you for some speed coding competitions.
Only for things that I already done 1,000 times.
No, that's cheating. No, great. Was that useful, David?
Yes, it is. I believe it all boils down to the experience that you get in the language. The first JSONet I was writing was more spaghetti, and now it's trying to. But now the problem is more on how to provide an API in JSONet without bleeding too much JSONet into the user's hands, and that's the hard part. So, because we're really a generic tooling that, if you have a Docker file, we don't ask any questions. We just build the image. We make a deployment for you with all the Tanka tooling, and that's my part. I maintain that. So it's really easy for the users. They just say, okay, spin off the CI. I don't want to talk to Kubernetes, but I want to talk to my service though. So it works. It works, but some users need some small modifications. So this is the interface part between the user and the JSONet that's harder. I would say just do JSONet, but they don't want too much to learn JSONet. So
I think it's something that we found is that it's possible to interact with JSONet at various levels. So it's possible to interact with JSONet at this, the beginner level, where all you do is call APIs, call this dot new plus this dot feature with feature, and so on, and you just use it as a kind of like a domain specific language to call things that you copy and paste from places where other people did it. And then there's other people who actually write libraries that do things more cleverly. And there's a demo, I think, is it the previous Tanka call? I gave a slide presentation of some advanced JSONet features. And there's another one I could give, which is about how do you create systems that use mix-ins, which is when JSONet really kind of kicks off. So I think those are sort of the three levels. Is a library consumer, library creator, and mix-in library creator. Are the three sort of levels of JSONet skill. I
think Tanka and overall Grafana ecosystem for JSONet is a really good inspiration for organizing code. I've read a lot of that, so yeah.
Good.
Yep.
Well, thank you all. We've now hit our 1 hour limit. So unless anyone's got anything else to add or ask.
Thank you all for joining. You can always come and bother us on Slack. The Grafana Slack is something we hang out in.
Yep, so on the #Tanka channel. Hopefully we'll see you all there.
See you. Bye-bye.
Thank you very much.
Bye.
Thank you. Bye.